Welcome back. I know your head is spinning after that first chemistry video, but we're learning so much, and I know we're cramming. You know, that was a 20 or 30 minute overview. Okay. Now we don't expect you to be experts on chemistry, so we're going to really hone in and try to focus on the important things for human anatomy and physiology. So that being said, we just finished with Lewis dot structures. So let's do the Lewis dot structure for chlorine. Okay. So for chlorine, it's kind of cool. We put the symbol. Okay. And then we look at that on the periodic table, and chlorine is in group 17, okay? So chlorine is group 17. Well, once again, what's kind of cool is remember all the teams have so many valence electrons. So group 13 has 3, 14 has 4, so 17 has 7 valence electrons. Cool, okay? So here we go, so let's draw 7. Remember there would only be 8, remember it's just 2 per side, okay? So we draw 7. 1, 2, 3, 4, 5, 6, 7. Oh, well, here we go. Now what does this tell me? This tells me that there's one spot left that it wants to be stable. Remember at the very beginning we said everything wants to be stable. So now let's put this together here, and let's put a sodium right here. Okay, we come over and we find sodium. Well, sodium's in group 1. Oh. Now, every time we draw a Lewis dot structure, it doesn't matter what shape we use. X's, O's, triangles, squares, American flags, skull, crossbone. It doesn't matter to me. Okay. But every time you draw one, you have to make a different shape for each different element. So chlorine is the X's, okay? So let's make sodium zeros here, or circles. And look what we have here. Okay, so this is sodium chloride, okay? Also known as table salt, also extremely important in your body. We need some salt, okay? We're going to talk a little bit later about how the sodium breaks down. But look what we have. Oh, so what we have here is we have the octet rule. You remember that? We have the octet rule. Oh, so is that good or is that bad? That's great. That's great. It has 8. It's stable. The chlorine's happy. The sodium's happy. We got together. Oh, we bonded together. What kind of bond? Oh, this is called a covalent bond. We made a covalent bond, which is simply covalent means it's a Latin word for sharing. So this is a sharing of electrons. So covalent bond, sharing of electrons. So anytime something can combine, then we stick it on there, okay? So let's look at something else, okay? So let's look at something else. Let's take carbon, okay? Let's take carbon. And once again, we look at carbon, and carbon is in group 14, so it has 4. 1, 2, 3, 4. Oh, well, carbon is probably, well, let's see, what's 78% or so of your body's carbon? I could be wrong on that, we'll check, but most of your body is carbon. So the reason why is, look, carbon is solid, but it has all these bonding sites. Oh, so if I want to bond an oxygen to that, okay? If I want to put an oxygen over here, okay, what group is oxygen in? Okay, 13, 14, 15, 16. Oh, so oxygen is in group 16, so I can put an oxygen up here. So that is group 16 means 6 valence electrons. 1, 2, 3, 4, 5. Oh, wait a minute, something else is going on here. Oh, now that oxygen, oh, there's another spot. So something else is going to bond there. Wherever there's a spot, something's going to bond. And you know what bonds to this? It's kind of cool. You know what happens? It bonds another oxygen on there. We make carbon dioxide. So every time there's an empty electron, something is going to bond. Now, it could be that the carbon does this and only bonds to something over here. And in this case, it actually bonds with another oxygen most of the time. So that was circles. So let's make this one triangles. Once again, oxygen is how many? 6, because it's in group 16. 1, 2, 3, 4, 5, 6. Oh, well, wait a minute. Is it stable or is it unstable? Well, looks pretty stable, except that there's an unpaired electron. Oh, well, you know what let's do? Let's make a square here. Cool, there's a hydrogen. Oh, good, stabilized, okay? Now, we've already used a square for that hydrogen, so now let's use a little asterisk Oh, cool, there's another hydrogen. So as we see, there's all kinds of things we can do, and they keep trying to become stable until all the electrons are paired. Okay? So once again, we're looking to say to ourselves, what's a covalent bond? Sharing of electrons. Okay? So once again, just in a nutshell, whenever we say it's a covalent bond, they share electrons. What's the common goal? What is covalent? What is the come together and share? Covalent bonds make both elements stable. Oh, well, it took us a while to get back to stable, didn't it? So covalent bonds make both stable. We share to try to get the octet rule, or if nothing else, make sure all the electrons are paired with another electron. Okay? All right. Now, let's move on to ionic bonding. There's two types of bonding that we're going to look at. Okay? There's two types of bonding. The first one we have is covalent, sharing of electrons to become stable. Now, the other type of bond that we have in human anatomy is called ionic bonding. Okay, ionic bonding. Okay, an ion is a different number of electrons. Okay, so let's just use carbon, since we know that it has. Let's just use carbon for a little bit. Since we know that it has four valence electrons. Okay, so carbon. Okay, carbon has four valence electrons. 1, 2, 3, 4. Okay, so carbon has. Okay, all right. Actually, let's yeah, we can stay with that. Okay, 1, 2, 3, 4. So every electron has a negative charge. Okay. So if carbon is missing an electron, okay, all right. So let me come and draw. Let me draw a little more of this, okay. I don't want to cut this short and be confused, okay. Let's look at this for example. Let's go with carbon, okay. Let's go with carbon, all right. The atomic number is 6, okay. The atomic number is 6. So here's carbon, okay. So it has 6 protons, okay. How many neutrons? The atomic number is 12 minus the mass number is 12 minus the atomic number is 6, so that's 6 neutrons. Cool, okay? Now, when I look at carbon is in, I'll get my cameraman to come up here real quick, okay? This is kind of cool, okay? This is kind of cool. So so now we're going this way. We got groups up and down. This is period 1, period 2, period 3, 4, 5, 6, 7, okay? So these are the periods. Now, where's carbon in? Carbon is in period 2. Oh. So what does that tell us? That tells us that this is 2s2. Oh, well, let's come over here. What that means is this. So it has, here's the S. So there's 2 electrons here in the first S. Oh, that's cool. But carbon also, since it's in the second period, it has 2 s orbitals. Oh. Cool. So I have 1, 2, 3, 4. Oh, nice. So that second period tells me that there's 2 s orbitals. Now, so I look here, and then carbon has 6 electrons. Well, I've already got 4 electrons in carbon, so here goes the p's. Boom, here they come out. Nice. Okay. But how many p's are in that one? So 13 is so boron is P1. Carbon is P2. Oh. So there's only 2 electrons. There's only 2 electrons. Hey, that kind of looks like a SpongeBob character there. Okay. There's only 2 electrons in that P. So in reality, that's what that carbon looks like. Oh. How many valence electrons do they have? Oh, well, here's carbon. Carbon is 1s2. Let's do this. 2s2. 2p2. Because everything below it makes up the kernel. So there's hydrogen and helium, that's the S1 and S2. Lithium and beryllium, that's a 2s2. And then here's 2p1, 2p2. Now how did I know it was 2? Oh, because it's in the second period. Now, don't get wrapped up in that. That's okay if you're kind of losing that. So what do I do? So valence electrons are everything in that period. Oh. So there's 4 valence electrons. And how did I know that was the second? How did I know these numbers were 2? Because it's in the second period. Oh. Now, I don't expect you to really understand this really good. Just want you to get a gist of this. But what if that carbon, okay, what if one of these electrons get loose from this carbon and it goes over here to do something else? Oh, wait a minute. So that carbon then is not stable anymore. Instead, that carbon lost an electron. Okay, that carbon lost an electron. Well, what does that mean? Okay, so the atomic number, once again, I'm going to try to wrap this up. The atomic number is 6. Okay, so it should have 6 protons, 6 electrons. So 6 positives, 6 minuses, should be 0. But now this carbon lost an electron, so now this carbon has 5 electrons. Oh, what's the charge? Oh, wait a minute, that's a +1 charge. Oh, so you mean to tell me that an ion with a +1, what did it do? Oh, it lost an electron. Oh, cool. Okay, is that good or is that bad? That's bad. It's going to do something to get stable right away. Human anatomy, here we come. Okay. Human anatomy, here we come. Okay, now, so if I show you this, if carbon is a -1, what did it do? Did it lose or gain electrons? Well, carbon -1 means this. That means it's got an extra electron. It has 7 electrons, so now it's a -1 charge. Oh, wait a minute. Oh, so -1 means that it gained an electron. And trust you me, it wants to get rid of it in a hurry. And trust you me, this carbon's going to find one in a hurry. Because it's not thinking like, oh, gee, I'm feeling a little uncomfortable. Okay? No, it's like, if I don't, I'm going to die, and I'm not going to exist, and it doesn't have a brain, and it does nothing except want to get stable. Oh, so isn't this kind of a good deal? Let's take this. Let's say that sodium, okay? Let's say that sodium came in there, okay? And let's say that sodium gained an electron, so it's a -1 charge, okay? So that it gained an electron. See, minus means it gained because the electron's a negative charge. And let's say that chlorine over here, okay, lost an electron. Oh, boy, they are searching the world over for each other because they can get together and be NaCl and have a 0 charge. Because this one had a -1 and this one had a +1. Oh, so let's take another one for example. Let's take potassium and fluorine, okay? And let's say this potassium is a -2. It gained 2 electrons. And so out there in the world, it is looking for something, and here's a fluorine out here that has a +2. Oh man, they're going to find each other. They're going to be like 2 magnets. Boom! And they're going to get together, and all of a sudden they're going to love it because what? Because now they got the right charge. They don't care about sharing like we talked about a while ago, like group 1 goes with group so-and-so, and group 2 goes with so-and-so. That's cool. Except now we're dealing with ionic bonds, okay, where the charges equal 0. That's critical. That's human anatomy. That's what happens. Whenever we put something in our body, how do you think medicines work? We put stuff in that's charged to try to get rid of other charges. We have neurotransmitters in our brain that send all this information. How does it work? Because it changed charges. Oh, we have a heartbeat because we have a 0.5 millivolts of charge because we have an imbalance of electrons. Okay? So here's the deal. We talked about all this chemistry to get to this. What do we got? Covalent bonds. Shares electrons. That's cool. That's good. Why to be stable? Okay? So that all the electrons are paired. But then we have ionic bonds. What do? They share charges to equal 0 to become stable. Once again, if you see a -2, then it has 2 extra electrons. If it's a +2, then it lost 2. Here comes that lightning bolt. Whoosh! And it's going to do what? It's going to find unstable charges. Would you think that your body is mostly positive or mostly negative, and you would think that your body is a charged particle, but the problem is we're constantly uncharged. There are free electrons in our body all the time. The question is, how do we get rid of them and what do we bond to? So what happens is,